Okay, congruent segments. Guys, we're going to explain congruency today. Guys, don't write this down and just watch for a second what I'm doing right now. Okay? On this different sheet of paper, what I'm going to say to you is, let's say I had a segment right here, and then another segment right here. Distance from here to here was 5, distance from there to there was 5. Okay? Right now, all you can say is that AB is equal to CD. And remember that AB means what? The distance from what?
A to B.
So what we're saying here is that 5 is equal to 5. Does everyone agree with that? Okay? 5 is equal to 5 there. Okay? However, it would not be right to say this. Can anybody tell me why? Yes. What do you think, Court? It's okay. It's okay to be. You're probably thinking right, you just don't know how to say it, right?
No, I don't think you know if I'm thinking right.
Well, you probably are. It's a pretty simple concept. When you say things are equal, you're saying they're the same, right? Would everyone agree with that?
Yes.
Okay. Is this segment the same thing as that segment?
No.
It's really not, is it? What they are is the same what? Well, same size, maybe? How about that? Same length? Lines, segments don't have shape, but if they did, you'd say, and they were congruent, you could say they're the same shape. So what happens is geometry developed a word. See, the reason you can say these two are equal is because you're talking about numbers, right? 5 is equal to 5. Okay? But the reason we don't say this is because what we say is we say that segment AB, and we use this sign right here, which means congruent, is congruent to segment CD. This sign right there means congruent. Okay? What congruent means, it is of course not in the book like this, but I like to tell people it means same size and shape. Doesn't mean they're the same thing, just means they're the same what? Size. Okay? You'll find when we worry about polygons, and what a polygon is like a triangle, a rectangle, things like that. These sides determine the size, and the angles determine the shape. And we'll get into that later when we talk about congruent polygons, okay? But since we're just dealing with a segment here, all we really have to worry about is the size, because we really don't have shape yet. There's no angles in a segment, is there? But mostly we're going to introduce the word congruent, which is like a combination of the equal sign and approximately sign. This means congruent, this right here, that sign. Everybody okay with that? Does that make sense? Okay? Any questions on that? You think you understand what congruent means? Okay. Congruency is, first of all, one, it's reflexive. Segment AB would be congruent to segment AB. The same things are congruent, aren't they? That makes sense, right? Congruency is also symmetric, and that it doesn't matter what order. If AB is congruent to CD, then CD is congruent to AB. It is also transitive which says that if AB was congruent to CD and CD was congruent to, we'll say, EF, then AB would be congruent to EF. If two things are congruent to the same thing, they have to be congruent to each other.
Exactly.
Okay? Congruency will probably be the one new concept that you will deal with the most here in geometry. Okay? How are those notes coming along, Damon? Would you like me to own that phone? Where the should it be? Get it there. Where's your notes at?
Not back there.
Let's get that done too. Now, the next important thing to talk about is something called a midpoint. If you knew nothing about anything and you saw the word midpoint, what would your first thought be?
A middle point.
A point that's in the what?
Middle.
How about a point in the middle of something? That's what I would do. That's what I would say. You know what? In essence, you'd be right. Now, we're a little more specific about it here in geometry. If you had point A and point B and we called this M, and we said M is a midpoint, what do you think I could say? What do you think M does? How about say M cuts
Bless you.
AB in what? It's right in the middle, isn't it? Now, realize that, have you guys noticed that we like to draw pictures in geometry? Okay, it's because they're sometimes the best visual representation of what's in front of you. Okay? What you'll see is you'll see a mark like this sometimes. Does anybody know what that means?
Yes, they're congruent.
They're congruent, they're the same length. Okay? So if the distance from here to here was 10, what would that distance be? It'd be 10 too, wouldn't it?
Yes.
Because that's the midpoint. So when I say something is a midpoint of something, I know that the two pieces created are what? Equal. Congruent. Correct? We also have another situation here. We're going to draw. Draw yourself another segment. We'll label it AB. We'll draw a point right in the middle. We'll label it M again. We'll say M is the midpoint again. What we're going to add to this picture is I am going to draw a line that goes right through him. We'll call it line L.
Line L.
Yes.
Why are you?
Because it's another thing for line.
Cursive. Remember the cursive name, cursive lowercase letter
Yes.
represents a line sometimes?
Oh, yeah.
Another important word here that you're going to deal with a lot. Because L, what does L do to AB? L what?
Splits them.
Or cuts AB in what? Therefore, L is said to, here's the new word, bisect AB. So when they say something bisects something, what are they saying? Cuts it in half. Okay?
Let's say
Therefore, L cuts AB in half, period. Therefore, L is said to bisect AB. So whenever I say something bisects something, what am I saying it does to it?
Cuts in half.
From now on, you hear that word bisect, whatever they say, whatever it bisects, it cuts in and creates two equal parts, does it not? Whether it bisects an angle, whether it bisects a rectangle, whether it bisects a side, you know, things like that. When it bisects something, it cuts it in half. So what's created here? What could I mark right here on AM? I can put a mark here and a mark here to say that this is congruent to what?
that's right.
Right? Start with a very easy example. Find AM. If AB is equal to 16. You know why you guys are confused? Because you're looking at this, and if I had no picture drawn, would that make any sense at all? Would you agree with that? It wouldn't make any sense at all. But with this picture labeled the way it is, if I'll go up to here and say AB is 16, and just make something like this, and say that whole thing's what?
16.
So what would A to M be now?
A.
See how easy that was?
L separated.
But if you read just that, does it look like I'm asking you something in a different language?
Yeah.
Agreed. If it ever reads like that, you read something that looks like a different language, you know what, you're probably, I mean, sometimes you may just be misunderstanding the question, but you're probably not reading all the directions. There's probably some information you haven't taken into hand yet. There's probably a picture you haven't looked at. You know what I mean? So, it's amazing how easy the concept and actual math we did. I mean, what's the math we did there?
Simple second grade math. Cut in half.
Yeah, I told you that these two are the same length. I mean, I could probably write up a second grade or a third grade math problem. Okay, Johnny walked 16 feet. John walked half as far as him. How far did John walk?
8
Okay? In essence, what you guys consider math, that's what we did there, wasn't it? Okay? So, the concept of understanding what midpoint is, what bisect means, and having the picture is really the only new part of that. And that's not that hard a concept, is it? It's just learning the language. Okay?
see me? No. I'm gonna take you home.
Settle down.
I want to be king.
Let's do a couple of these examples. Gotta get you one more, so you can pass those two.
Coach Stone. Tonight for the team dinner.
I don't wanna talk football right now.
I want to talk for a while. I'm talking about like.
I don't wanna talk to you then. Talk geometry.
Okay. When can we talk?
You're on my bad side right now anyway.
All right. When can we talk team dinner?
Fifth hour.
Dang. All right.
And when you earn the right to talk to you, then by
All right.
not being a lazy butt like you've been the last 2 days. For me, I don't love you. I don't like you. I just want you to do better. Court, don't you guys laugh either. You guys are rich. Okay. Let's look at some of these. Okay. Use the number line to determine whether each one is true or false. Okay, it says that W is the midpoint of QR. So what they're saying right here from this picture is that this is right in the middle of Q and R. Is that possible? No. Distance here is 1, the distance here is 1, 2, 3. Obviously it's not in the middle. So that is false. We explained, I'm not going to write down the explaining of the reasoning because we just talked about it, didn't we? But that's something you would write down. S is the midpoint of TV. Is that true or false?
Is
2 and 2. It's right in the middle, isn't it? True. SB is congruent to TS. SB, is it congruent to TS? That's true. V is the midpoint of TW. T to W.
Yes.
Well,
No, it's not.
I don't know. Let's look.
It's not.
yes.
What
Yeah,
Yes, it is.
we got to get those two distances right.
Yeah, it is.
1, 2, 3, 4. 1, 2, 3, 4. So yes, that's true. You're getting some of these longer ones, it may not just jump out at you. W is the midpoint of VR.
No.
No.
False. Okay. SW is longer than VR. SW is longer than VR. Well, SW is what? 1, 2, 3, 4, 5, 6. VR is 1, 2, 3, 4, 5, 6, 7. So is SW longer?
No.
No, VR is longer, so that is false. Okay? You guys get the gist of what we're doing there?
Yes.
Do we use the number?
Is this true or false here?
That's true.
Segments, it doesn't really matter where you start as long as you say the two endpoints, correct?
Yeah.
So I'd say that's true. And what I would say is that's the reflexive property. Because you could rewrite this as, it's not symmetric because they didn't do the order. Now, AB is congruent to BC, BC is congruent to XY. Does AC have anything to do with that?
No.
No, so this is false. How would it have been right
If it was AB.
if this was AB, right? Because then that would have been transitive. But it was AC, so it was wrong. Now, for number 14. Well, let's look at 12. AY is congruent to XR, XR is congruent to AY. What is this? Isn't that true? It's just the order we wrote them on each side. Oh, sorry. What property tells me that's true? Symmetric property. Okay? For number 14, I want to put a completely different example. And I'm sorry. So let's say if AM, zoom in a little bit here. If AM is equal to 3x plus 4, BM is equal to 4x minus 8, and M is the midpoint of AB, find X and AB. Focus that a little bit. So write that problem down. After you do so, we are going to work it out.
What else do we need to find?
AB, the distance from A to B. Anybody tell me what we talked about in section 2.2 that I may have said was a big deal that you're going to do over and over and over again? If something looks like a algebra problem, what do I need to probably create? An equation. All right, you got this written down. Everybody put your pencils down. Put your pencils down if you've got the problem written down. Once you do, put your pencils down. Jacob. Jacob. Watch me do this one. I know you know how to do it, but just do me a favor. All right. First of all, I said M is the midpoint. Well, I guess the first thing the problem says that AM is 3x plus 4. It will help you to write what?
3x plus 4.
Right here. If it helps you to kind of go like that, to point out that it's from there to there, that's fine. Okay, whatever helps you. Right, Dean? Come on.
Yes, sir.
What about BM is what? 4x minus 8. That's the distance from here to here, correct? Everybody okay with that?
Yes.
The other stuff the problem gave me that I accept to be true is that M is the what?
Midpoint.
What does that mean? It cuts it in.
The middle.
It's right in the middle, so this is congruent to what? Okay. First of all, I'm supposed to find X. I probably need to create, like I said before, a what? I need to use the information given to create a valid equation. Now, if the equation's not jumping out at you right now, some of you it may be, some of you it may not, do this. Ignore what you have here and put a regular number here. If here to here was 5, you guys know what here to here would be?
5.
Do you know two things that are equal there?
Yeah.
Aren't the 5s equal?
Yes.
Basically, in essence, what I'm trying to say to you is this thing is what? Equal to that thing, right? Would you agree with that?
Yes.
Is that an equation? Two things being equal?
Yes.
Yeah, an equation means you have an equal sign. right? So what's, two things are equal? 3x plus 4 and what? 4x minus 8 are the two things, and they are what?
Equal.
Have you created a value equation from the information given?
Yes.
Now the only thing left to do is solve for x.
12.
Subtract 3x. You'd be left with 4 is equal to what? X minus 8. What would you do now?
Plus the 8, you get 12.
X is equal to 12. So I've found part of the problem. And you guys need to pay attention, because a lot of these types of problems, they won't even say find x, they'll just say find AB. I would hate for you to go through all this work, do a good job of finding the equation, and then you don't pay attention to what they want. Now, so I've got to find what AB is. Well, ignore my 2 5s I wrote up here, because that was just pretend, but trying to help you visualize what's equal to what. I know what x is, right? It's 12, right? So the distance from here to here is 3 times what? Plus 4. Would everyone agree with that?
Yes.
Distance from here to here is 4 times what?
12.
Plus 4.
Minus.
3
Minus 8.
minus 8. I'm sorry. Minus 8. You get 40 here. What do you get here?
40.
So what is the distance from A to B?
80.
40 plus what?
40.
So AB is equal to what?
80.
80.
Ooh, I got that one wrong. Get that one right.
Okay.